Alright, so we're going to take a look at Arithmetic Series, which is section 1.2 in your textbook. And before we get into discussing the formulas, just a reminder that a sequence is a list of terms. So for example, you might have 2, 5, 8, 11, ... Okay, so it's a list. We show a list by putting commas between our numbers. And a series is a sum of the terms. So if I take this sequence here, I'm going to add the terms this time. So I replace my commas with plus signs. And so I'm going to go 2 plus 5 plus 8 plus 11 plus ... Okay, so there are two formulas that we use to determine sums of series. The first one is S subscript n equals n over 2 times t1 plus t subscript n. And the second one is S subscript n equals n over 2 times 2 times t1 plus n minus 1 times d. Okay, in the first one and the second one, t1 is your first term, and for both of them, n is the number of terms. On the first one, you will need to know what t subscript n is. It is the nth term. And notice on the second one that you don't need to know what t subscript n is. Instead, you need to know what d is. So d is the common difference. And for both of them, s subscript n is the sum of the first n terms. Okay. Now, sometimes these formulas can be called partial sum formulas, because if you have an infinite series like this one here, you can't possibly calculate the sum of an infinite series, so you would be asked to find a partial sum. So for example, the sum of the first 10 terms or the sum of the first 20 terms. Okay, so you use the first formula when you know what t subscript n is. Okay, and that would mean the last term in the series you want to calculate the sum for. Okay, and the second formula you would use when you don't know what t subscript n is and you know what d is instead. Okay, so you use this formula when you don't know what t subscript n is. Okay, so let's take a look at our first example. You've been asked to find the sum of a series, and the series that you are given is 2 plus 7 plus 12 plus ... plus 62. So this is a finite series. Okay, we don't know how many terms are in this series, but we do know that our first term is 2. We also know that our common difference is 7 minus 2, which is 5. And even though we don't know how many terms there are in this series, we do know that the last term, which we're going to call t subscript n, is 62. Okay, so notice that we have t subscript n. So this means we're going to use the second formula. Okay, which is S subscript n equals n over 2 times t1 plus t subscript n. Okay, now take a look at what we know in terms of our formula. We know what t1 is and we know what t subscript n is, but we don't know what n is. So we're going to have to find n first. And the way we're going to do that is to use our general terms. So we're going to use t subscript n equals t1 plus n minus 1 times d. Okay, in place of t subscript n, I will put 62. In place of t1, I will put 2 plus, I do not know what n is, but I do know that d is 5. So I'm going to solve for n. I will start by distributing the 5, and I get 62 equals 2 plus 5n minus 5. Combine my like terms. 2 minus 5 is negative 3. Bring the negative 3 over to the right, or the left, sorry, and it becomes positive. So 62 plus 3 is 65, and divide both sides by 5, and I get 13. So I know that there are 13 terms in this series. Okay, now I can find my sum. Okay, I want the sum of this series. Now, because I know that there are 13 terms, I'm looking for S13. Okay, so my formula is S subscript n equals n over 2 times t1 plus t subscript n. And so I'm looking for S13. N is 13. T1 is 2. T subscript n is 62. And using order of operations, I'm going to simplify what is on the right. So 13 divided by 2 is 6.5. 2 plus 62 is 64. And 6.5 times 64 is 416. And so the sum of the series is 416. Example 2, find the sum of a series. You are now given a sequence 5, negative 2, negative 9, negative 16, ... and you've been asked to find S50. Okay, so what you're given is a sequence, but you can only find sums of series, right? So really what they're asking you to do is to find the sum of 5 plus negative 2 plus negative 9 plus negative 16 plus ... and all the way up to whatever t subscript 50 is. Okay, because you want to find the sum of the first 50 terms. So in this example, we don't have t subscript n. Okay, so that means we're going to use the second formula. Okay, which is S subscript n equals n over 2 times 2 times t1 plus n minus 1 times d. Okay, so let's make a list of what we do know. We do know that t1 is 5, and we know that d is negative 2 minus 5, which is negative 7. And because we've been asked to find S50, we know that n is equal to 50. In other words, we want to find the sum of the first 50 terms. Okay? All right, so our formula and we want to find S50, so we're going to go write S50. We know that n is 50, so 50 over 2. And we're going to write a square bracket and 2 times our first term, which is 5 plus n minus 1, so 50 minus 1 times our common difference, which is negative 7. Okay, so now we're going to use order of operations to simplify the right-hand side of the equation. Okay, so we're going to go S50. 50 divided by 2 is 25. 2 times 5 is 10 plus 50 minus 1 is 49 times negative 7. And then we're going to go 25 times, and I'm just going to simplify everything inside the bracket at once. So 10 plus 49 times negative 7 is negative 333. And when we multiply 25 times negative 333, we get negative 8,325. And so the sum is negative 8,325. Okay, so that concludes example number 2. So example 3, find S subscript n. So we're going to look at 3 different questions here that are all asking you to find a partial sum. And so just slightly different information that you're given for each of them, and we'll just take a look at how to solve each one. So for A, find S20 given that T1 equals negative 15 and T15 is equal to negative 57. Okay, so let's write down what we know. We know that T1 is negative 15. We know that T15 is negative 57. And because we want to find a partial sum of S20, what we're looking for then is the sum of the first 20 terms. So we know that n is equal to 20. Now, also what you should note, because we are looking for the sum S20 and we don't know what T20 is, we don't know what T subscript n is. And so we're going to use our second formula, okay? And I'm just going to write it up here. Now, if you take a look at our formula here, we need to know what n is, which we do have. We know it's 20. And we also know T1, which is negative 15. What we don't know is D. So we're going to have to first find D. And in order to do that, we need our general term. Okay, and in order to find D for this, we're going to use our T subscript 15. Okay, and that's going to be our T subscript n. If that's the case, then for this particular calculation, we're going to use n equals 15. Okay, because that's what our T subscript n is. So I'm going to put in negative 57 here. And T1 is negative 15 plus, and like I said, because we're using T15, our n value is going to be 15. And we don't know what D is. Okay, so we're going to solve for D. So I need to simplify what's in the bracket. 15 minus 1 is 14, so that gives me 14D. I need to move the negative 15 over to the left. It becomes positive, and negative 57 plus 15 is negative 42. Isolate for D by dividing both sides of the equation by 14, and you get that D is equal to negative 3. Okay, so now you can find S20. Okay, so S20 then is equal to n, which we said will be 20. Divide it by 2. 2 times T1, which is 2 times negative 15, plus 20 minus 1 times our D value, which is negative 3. And you're going to simplify what is on the right-hand side of the equation. So 20 over 2 is 10. 2 times negative 15 is negative 30, plus 20 minus 1 is 19 times negative 3. And I'm just going to simplify what's inside the bracket. Negative 30 plus 19 times negative 3 is negative 87. And so S subscript 20 is equal to negative 870. Okay. And I won't write a sentence for that because I'm out of room. Okay, so B. Write the first 5 terms of a sequence if the sum of the first 11 terms is 242 and the first term is -8. Okay, so even though you're not looking for a partial sum on this, you are going to be using it because you're told that the sum of the first 11 terms is 242. Okay, so let's write what we know. We know that the sum of the first 11 terms is 242, so that means that S11 is 242. We also know that the first term of our series is -8, and because we have the sum of the first 11 terms, we know that n equals 11. Now, if you take a look at this, we don't have t subscript n, so we're going to use our second formula. Okay, so the formula we're going to use is s subscript n equals n over 2 times 2t1 plus n minus 1 times d. Okay, so take a look at the information that we have. We know what our s subscript n is because it's s subscript 11. We know that n is 11, and we know what our first term is, t1, at -8. Okay, what we don't know is d, so the first thing we need to do is find d. And that makes sense too because we want to write the first 5 terms of our sequence, and in order to do that we need to know what d is. Okay, so we're going to use this formula, and we're looking for d when we know that S11 or s subscript n is 242, so I'm going to substitute that in for s subscript n. We know that n is 11, so divide that by 2. 2 times our first term, which is -8, plus 11 minus 1 times d. Okay, so we're going to simplify what we can. 11 over 2 is 5.5. 2 times -8 is -16, plus 11 minus 1 is 10, so that gives us 10d. Now we have to distribute the 5.5. Okay, so that gives us 242 equals -88. Okay, because 5.5 times -16 is -88, plus 55d. Okay, because 5.5 times 10 is 55. And we want to move the -88 over to the left. It becomes positive, so 242 plus 88 is 330. And that's equal to 55. d, divide both sides by 55, and you get that d is 6. Okay, so now we can write our first 5 terms. So t1 we already know is -8. t2 will be -8 plus 6, which is -2. t3 is -2 plus 6, which is 4. t4 is 4 plus 6, which is 10. And t5 is 10 plus 6, which is 16. So the first 5 terms are -8, -2, 4, 10, and 16. Okay, so now we take a look at C. We want to find S50. We are given that T5 is 10 and T8 is 19. Okay, so what do we know? All right, well, because we want to find S50, we know that n equals 50. We know that T5 equals 10, and we know that T8 is equal to 19. Now, we don't know what our T subscript n is. Okay, we just know that we're looking for the sum of the first 50 terms, so we're probably going to use our second formula. Okay, so if we take a look at this formula, the only information that we know is what n is. We don't know what t1 is, and we don't know what d is, so we're probably going to have to find those. Okay, so we're going to start by finding d. Okay, so I'll do that here. And one way to do that is to draw a picture of what we have here. Okay, so we don't have the first four terms. Okay, so space, actually, let me do that here. Space, 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 but we do know that t5 is 10. And we don't know what t6 is. We don't know what t7 is, but we do know that t8 is 19. Okay, and then dot, dot, dot. Okay, so what we have then, this is t1, t2, t3, t4, t5, t6, t7, and t8. All right, well, we want to find d. We're probably going to have to use our general term. Okay, but as you can see from up here, we don't know what t1 is, and we don't know what n is, so we can't, and we don't know what t subscript n is, so we can't possibly find out what d is. Okay, but what you could do is you could plug in t1 as being 10. Okay, so why don't we just rewrite this and just say that t1 is going to, we're just going to rename the 10 as t1. So if we rename the 10 as t1, then we can rename the t8 as t4, right? Okay, because if this is t1, then this will be t2, t3, and t4. Okay, so don't get confused. We're just renaming these so that we can use the formula here. Okay, so now you can see by looking at this that we're going to plug in 10 for our t1. And we're going to use t subscript 4 for our t subscript n, so that'll be 19. If that's the case, then our n is 4. And now we can find d. Okay, so we're going to go 19 equals 10 plus 4 minus 1 is 3, so 3d. Bring the 10 over, it becomes negative. 19 minus 10 is 9. Divide both sides by 3, and you get that d is equal to 3. Okay, so now we know d equals 3. So if we go back to our formula, we now know that d is 3, and we know that n is going to be 50 because we're going to use the 50 off of the S50. We still don't know what t1 is, but we can probably find it now because we have enough information. So the next thing we're going to do is find t1. Okay? And once again, we're going to use our general term. Okay, and we're also going to use the information once again that we have here. All right, so I can either take the 10 as being t5, okay, or I can use the 19 as being t8 and use that in this formula to find out what t1 is. But I'm going to go with the smaller number. I'm going to use the 10 and the t5. Okay, so if I use the 10 and the t5, then my t subscript n is going to be my t subscript 5, so 10. Okay, I'm going to put 10 here. I'm looking for t1, and because I'm using t subscript 5 to find t1, I'm going to have n as 5. So I plug in 5 for n, and I know now that d is 3. And I am going to now solve for T1. So 5 minus 1 is 4, and 4 times 3 is 12. I'm going to bring the 12 over. It becomes negative, and 10 minus 12 is negative 2, and so I have that T1 is negative 2. Okay, so now we can find S50. Okay, we have enough information now. We know that n is 50, we know that T1 is negative 2, and we know that D is 3. So we're going to find S50. We're going to plug that into this formula here. So we're looking for S50. That's equal to n divided by 2. So 50 divided by 2. And 2 times T1. So 2 times negative 2 plus n minus 1, which is going to be 50 minus 1 times our common difference, which is 3. And so we're going to simplify everything on the right-hand side. So 50 over 2 is 25. 2 times negative 2 is negative 4. 50 minus 1 is 49 times 3. And so I will simplify everything inside the bracket. Negative 4 plus 49 times 3 will give you 143. And so S50 is equal to 3575. 3,575. Okay, a lot of work for one question. Example 4, determine the terms of an arithmetic series. So we're going to take a look at two examples here that are fairly similar. On the first one, you're going to have two consecutive sums of the same series. And on the second example, you're going to get two sums of the same series, but they won't be consecutive. Okay, so let's take a look at the first one. It's easier. You are told that the sum of the first 4 terms of an arithmetic series is 58. And the sum of the first 5 terms is 85, and you've been asked to find T1. Okay, so you don't really know a lot. You do know that the sum of the first 4 terms is 58, so that means that S4 is 58. And you are told that S5, okay, is 85. Okay, so the sum of the first 5 terms is 85. Not a lot of information, but maybe we can get some more. All right. So let's start by just taking a look at what S4 means. S4 means that if you take the first 4 terms of your series and add them all up, you should get the sum of the first 4 terms. S5 means if you take the first 5 terms you should get the sum of the first 5 terms. Okay, so take a look. You know that adding the first 4 terms of the same series will give you S4, and adding those first 4 terms of the same series should give you S4, right? So could I not take this and replace it with S4 plus T5 equals S5? Okay, and hopefully you can see now that we're able to calculate T5, okay, because I know that S4 is 58, and I know that S5 is 85, so T5 is going to be 85 minus 58, and so I will get that T5 is equal to 27. Okay, you can generalize this by saying that T5 will equal S5 minus S4. Okay, so over on this side now I can write that T5 is 27. Okay, and because this is my T subscript n, okay, this is T subscript n, I know that n is 5. All right, and because I know that T subscript 5 is my T subscript n, I'm going to be using my first formula, okay, and that's S subscript n equals n over 2 times T1 plus T subscript n. Okay, so I know that S5 is 85, I know that T5 is 27, and I know that n equals 5. I'm going to use this information to find T1, okay? So because n is 5, our S subscript n is going to be S subscript 5. I will place 85 in that position. And then n is 5, so 5 divided by 2. I do not know what T1 is. And I know that T subscript n is going to be my T subscript 5, which is 27. Okay? And then I'm going to solve for T1. So 5 divided by 2 is 2.5. And I'm going to times that by T1 plus 27. So I have to distribute. And so I get that 85 is equal to 2.5 times T1 plus, and 2.5 times 27 is 67.5. I'm going to bring my 67.5 over to the left. 85 minus 67.5 is 17.5. Divide both sides by 2.5, and I get that T1 is 7. Okay, so I found T1. Okay, now our next question is asking us to find T1 again, but notice that your sums are not consecutive. You've got S3 and you've got S6. Okay, so that changes things. And in order to do this question, we're going to review our systems of equations solving by elimination. Okay, and I've got 2 examples here, and I will go through the first example with you in detail, and then I'll just work quickly through the second one, and you can follow along. Okay, now remember from last year that when we want to solve by elimination, we want to eliminate one of our variables. So when we look at the first question here, we can see that probably the easiest variable to eliminate is going to be the y, because on my first equation, okay, equation 1, and I'll call this equation 2. On equation 1, my coefficient in front of the y is -1, and I can give it the same coefficient as my second equation simply by multiplying my first equation by 2, right? Okay, now granted, when I multiply through by 2, I'm going to get -2 instead of +2, but that's okay, because if my signs are opposite on my y's, then to eliminate the y, all I have to do is add. Okay, so that's going to be easier. All right, so I'm going to distribute my 2 throughout the whole first equation. That's going to give me 4x minus 2y equals 18. Leave my second equation as is. Okay, and as you can see, if I add these 2 equations together, I can eliminate my y. Okay, I'm going to go -2y plus 2y. That gives me 0y. Okay, so let's add. 4x plus 5x is 9x. -2y plus 2y is 0. I don't have to write the 0 down. And 18 plus 9 is 27. Notice I no longer have a y. I'm going to solve for my x by dividing both sides of my equation by 9, and I get that x is equal to 3. Okay. All right, I'm just going to make a note here to eliminate y. Okay. All right, so how do we get y then? We substitute x into one of our 2 equations, and I'm going to substitute it into my first one. Okay, and remember, when you're looking for the second variable, you should always substitute back into one of your original equations. Okay, so I'm going to plug in my x equals 3 into my first equation. That gives me 6 minus y equals 9. So negative y equals 3. And don't want negative y, so I'm going to multiply through by negative 1. Negative 1 times negative y is y. And negative 1 times 3 is negative 3. And remember, your solution for a systems of equations is an ordered pair on a graph. And so your answer, or your solution, is 3 and negative 3. Okay, so I'm just going to work quickly through the second one. Maybe you want to pause right now and try it out on your own. And then just, once you've worked it out, play the video again and see how you did. Okay, so I'm going to take this is 1, 2, I'm going to take this and multiply by 3, and I'm going to take this and multiply by negative 2 because I want to eliminate y. Now you can eliminate x2 if you like. Hang on, I am eliminating x, sorry. You can eliminate y if you like, but I'm doing the x because my numbers are smaller. Okay, so I'm going to distribute the 3 on the first one. That gives me 6x plus 9y equals 51, and multiply the negative 2 through the second equation. That gives me negative 6x minus 10y equals negative 20. And 6x minus 6x is 0. 9y minus 10y is negative y. 51 minus 20 is 31. And so y equals negative 31. Find x. I'm going to substitute back into the first equation. So 2x plus 3 times negative 31 equals 17. So 2x minus 93 equals 17. So 2x equals 110, sorry. And divide by 2 gives me 55. So my solution for the second question is 55 and negative 31. Okay, so this is going to help us on our next question. Okay. So you've been asked to find T1 knowing that S3 is 159 and S6 is 354. Okay, so you know that S3 is 159 and you know that S6 is 345. When S3 equals 159, you know that n is equal to 3. And when S6 equals 345, you know that n is equal to 6. And keep in mind that these sums are for the same arithmetic series. Okay, the equation that we're going to use in order to solve this is S subscript n equals n divided by 2 times 2 times t1 plus n minus 1 times d. Okay, so we're going to start by plugging what we know on the left here into our formula. So Sn is going to be S3. So in place of Sn, I'm going to put 159. N is 3. I don't know what T1 is. And I know that n is 3, so 3 minus 1. And I don't know what d is. And so I'm going to simplify as much as I can. Okay, so I get 159 equals 3 divided by 2 is 1.5 times 2t1 plus 3 minus 1 is 2, so 2 times d is 2d. And then I will distribute my 1.5, and so I get 3t1 plus 3d. Okay, I'm going to do the same thing for when S6 equals 345. Okay, so in place of S subscript n, I'm now going to put 346 because S subscript n is going to be S subscript 6. And so I go 345 equals n is 6 over 2. 2 times t1 plus n is 6 don't know what D is. Simplify what I can. 6 divided by 2 is 3. 6 minus 1 is 5. And distribute the 3. And that gives me 6t1 plus 15d. Okay, so we're going to work with these two equations here. And we're going to use systems of equations to solve for t1, because that's what you want to find. So if we want to find t1, and that means when we're using systems of equations, when I finish my first step here, I want my first step to read something like t1 equals a number, okay? So if that's the case, then I will want to eliminate my d, okay? So I'm going to eliminate d. Okay, so that means that my d's both have to have the same coefficient in front of them, okay? So if you take a look, this d here has a coefficient of 15, and this d has a coefficient of 3. If I want them both to have a 15 in front of them, then I am going to times this first one by 5, okay? Now, because I like adding when I solve for a systems of equations, I'm going to multiply this first equation through by -5 so that I get -15 here, okay? All right, so I'm going to distribute my -5 through, and I'm going to get -345 equals -15t1 minus 15d. And no, that's not true. Sorry. When I times this by this, I'm going to get -795 equals -15t1 minus 15d, and then I leave this one, my second equation, as is. Okay, and now I'm going to add. So -795 plus 345 is -450. And -15t1 plus 6t1 is -9t1. And -15d plus 15d is 0, so that cancels out. And notice you can now isolate for t1 by dividing both sides by -9, and you get that t1 is 50. Okay, so I know that's a lot of work, and hopefully you're not too overwhelmed. Example 5. Determine the sum of an arithmetic series, a word problem. Male fireflies flash in various patterns to signal location or to ward off predators. Different species of fireflies have different flash characteristics, such as the intensity of the flash, the rate of the flash, and the shape of the flash. Suppose that under certain circumstances, a particular firefly flashes twice in the first minute, 4 times in the second minute, and 6 times in the third minute. So let's summarize this information. Okay, we have up to 3 minutes, so we're going to write a number of minutes. So 1, 2, 3. And we also know the number of flashes for each minute. So for the first minute, it was 2 times, and the second minute, it was 4 times, and on the third minute, it was 6 times. Okay, so we're going to be asked 2 questions. On the first one, if this pattern continues, what is the number of flashes in the 30th minute? Okay, well, you could do that long way, right? You could say, okay, well, after 4 minutes, it must be 8, because I can see that my common difference is 2. And I could do that all the way up to 30, but that takes a long time. So there must be a simpler way to do this, right? Okay, well, if we want to calculate the number of flashes on the 30th minute, then our first term must be 2, and our common difference is 2, right? 4 minus 2. And because we want to find t30, that must mean that n must be 30, right? And we want to find t30 because we want the number of flashes on the 30th minute. Okay? So this is a sequence question. All right, so that means you're going to have to use your general term. Okay, and we want t30. We know that t1 is 2. We know that n is 30. And we know that d is 2. So t30 then is 2 plus, and 30 minus 1 is 29. Times that by 2. And when we simplify, we get 60. Okay? So the number of flashes in the 30th minute is 60. Okay, so B. What is the total number of flashes in 30 minutes? Okay, well, because they're using this word total, this means sum, right? And so you want S30. Okay, that's what you're looking for, S30. Okay, so what do we know? Well, we know that T1 is 2, we know that D is 2, and we know that N is 30. And we also know what T30 is, right? We know that that is 60, okay? And because our T subscript 30 is our T subscript N, that means we know what T subscript N is, so we can use our first sum formula, right? So we can use S subscript N equals N over 2 times T1 plus T subscript N. Okay, so S30 is equal to N, which is 30, over 2 times T1, which is 2, plus T subscript N, which is going to be our T subscript 30, so that's 60. So S30 is equal to 15, right? Because 30 divided by 2 is 15, and 2 plus 60 is 62, and so S30 is 930. Okay, so that's a very busy Firefly. All right, so the total number of flashes in 30 minutes is 930. Okay, and that concludes section 1.2.